Hello, and welcome to Let's Meet the Virologist, a podcast about the people behind today's virology headlines. People just like you, working to understand viruses and how they affect you. During the COVID-19 pandemic, we are talking with postdoctoral researchers involved in COVID-19 related research so that you can learn who they are and what they do. I am Larissa Thackeray, and I am hosting this podcast from America's Heartland in St. Louis, Missouri. One of the challenges of SARS-CoV-2 research is the requirement for biosafety level 3 laboratory facilities and special personal protective equipment to safely work with the virus. On September 1, 2020, we talked with Dr. Zhuoming Liu, a postdoc in the Whalen Lab at Washington University School of Medicine, who has been working on reagents to address this issue. Zhuoming obtained a master's degree in molecular microbiology in China studying plants, and a PhD in molecular virology from the University of Tokyo in Japan, where he studied a virus gene required for herpes virus egress. Hi Zhuoming, happy to have you with us today. Why don't you tell us a little bit about yourself? How did you become interested in virology research?
Regarding this question, I think I need to go back to my childhood. So I was born in the south of China and grew up in the countryside. And my brother and sister, play a lot outside. We do a lot of fishing, catch shrimps, and we are really close to the nature, plants, and insects and animals. So that's the first thing. And second thing is really amazing. My dad is really fond for the wine. So he normally makes the wine by himself. They cook the rice and put the yeast into the rice, and 2 weeks later, you got the sweet wine. That's really fantastic for our children. We like it so much, and then he concentrated it and got the wine. So at that time, I think this is the first time I felt that, there's so many powerful energy for the microbes. This kind of little guy is. And when I get to the college, I study plants. It's called Eastern olive tree. It can produce the seed, can make the oil. What I'm trying to do is use the molecular biology technology and put some of the gene into this tree and improve the productive and also make more oil. That's what I'm doing. And then I went to the master's degree. What I'm doing is trying to find out some of the gene is encoded by bacteria. We called it, this bacteria, we called it Bacillus thuringiensis. This bacteria, they encode several pesticide genes. This gene encodes the pesticide crystal protein. Once the paste got this protein can pump the epithelial cells of intestine of the paste and make the paste dead. So our goal is try to find these novel genes and put into the plants and improve the productivity of the plants. During my master's degree, I have the really good chance to do the internship in Japan in the Hokkaido University. I went to the laboratory, Dr. Miyazaki's laboratory. So actually, previously, our majority work is for the plants and bacteria interplay. This is my first time I have the chance to manipulate the mammalian cells and the small gut virus. And I still remember my first experiment, really classic experiment. My tutor is the postdoc in his lab, named Harada-san. He teach me how to plaque assay. So that's really basic, really classic experiment. I think this experiment is the basis for all the virology laboratory. Because virus is so tiny, you cannot see it. This is the way you can measure how many of the virus you got it, and also it's kind of really classic way you can say, how the virus is strong, how they're spreading. So that's I still remember this experiment. I used the H3N3 N2 influenza virus, did the plaque assay in the A549 cells.
Tell us a little bit about your PhD work then. Where was that and what did you work on?
So first, since I want to study the virus, I tried to apply some of the scholarship. Finally, I'm really lucky to got it, the Japanese government scholarship, so I can choose to do what I want to do. And I still eager to work on the influenza virus because they infect so many people, and every year they have new. Every year, there's so many people get infected, and at the same time, every 5 or 10 years, there's a new kind of strain came out, make the pandemic. I want to do something for this pandemic. At that time, my professor called Kawaguchi Yasushi. He's really a young PI and did a postdoc in under the mentorship of Bernard Roisman in Chicago, and went back to Japan and set up the laboratory. And then I emailed to him, and he replied me really quickly and invited me to his laboratory and gave me the interview and talked with his lab members. And one thing he interviewed and let me know more about his laboratory and what his work. So he's working on the herpes virus, and then we talked really well, and he accepted me, and then I went to his laboratory for get into the herpes area. So that's the start for my PhD, and for the herpes virus, it's a different world.
How did you end up in the Whalen lab?
Yeah, at that time, after I get my PhD, I think I need to go to more training for the virology, and I want to do the training in the US. And as you know, here people, there's a lot of virology that did really good science here. So at that time, I write the email to Sean and say I want to do the postdoc in your lab.
Can you tell us a little bit about the research that you've been doing in the Whalen lab sort of pre-COVID? So what did you used to work on before the COVID pandemic?
So in Sean's lab, there are major two focus. So first part is working on the VSV gene expression. We are the VSV laboratory. We want to know this platform and know every detail of the genes, every part of the protein. So this is make the VSV as a really perfect platform for the vector. And the second part is the virus and the cell interaction. Because I have the background for some of the cells and virus interaction, so I choose the second part. So what we are doing is use the VSV as a vector, substitute the VSVG with the virus glycan protein. Major, I'm focused on the Western equal, encephalitis virus, and chikungunya virus. And then we got this recombinant virus because sometimes the authentic virus is the BSL-3 virus. You cannot working on it at the BSL-2 level laboratory. So you use VSV, got the chimeric virus, you can working on the BSL-2 library. If you got something, you can go to the BSL-3 and you can save a lot of time and energy and also resources. So we got this chimeric virus. My major work is to focus on the glycan protein. We set up the genome-wide CRISPR. We use the genome-wide CRISPR technology and to screen what kind of host factor involved in the entry process of this virus. And then actually, majority work almost done. And then COVID-19 come. We temporarily stop this research. I temporarily stop this research, and right now, finally, I can get back to work on some of our work. Hopefully, we will get this work done and get it published in the future.
So I guess to follow up on that, why don't you tell us a little bit about how you got into the COVID-19 research and what is some of the research you've been doing?
As you know, during we moved to the Warship from the Harvard under the leadership of the Sean. But actually, before the March, our laboratory, Science laboratory, is still really full functioning in the Harvard, and we have one graduate student named Paul Rusloff. He had studied to he already early started to work on the SARS-2 virus as there is some pandemic happened in the Wuhan in China. He is trying to make the VSV SARS-2 chimeric virus. This virus can express the SARS-2 spike protein. It's a really cool tool to study the viral entry and also present the antigens for the vaccine and for the small inhibitor screening. He worked day and night and finally get this virus rescued, because it's not a really easy virus to get to succeed. You have so many tricks. And then in the March, we package all things and move to the WashU. I still remember we get into the WashU, everything is unpackaged, and first get to hear me, Louis Marie, a postdoc in our laboratory, and Paul Rusloff, and then Mark Tatra, another graduate student in Science lab. And then we came to here, and in the March, the pandemic becomes serious in the US, and Sean gave us a lab meeting, and we should work together and much efficiently. Hopefully, we can do something for this pandemic. So all the lab members, these 4 lab members, not a lot, it's just 4 at the beginning. But later we got more people join the lab, like Spencer and Brain, Casey. But at the beginning, during the first week, we unpackage all the stuff and set everything up and make the tissue culture room work. Actually, at first time, you will find that you move from one place to another place, sometimes never works. And we also lack of the tubes. And that timing, I think the community is really helpful. We email with the people because we need some special tubes to rescue the virus and grow the virus. And people really kindly replied to us, and we got really help from them. At that timing, during the first week, we set everything up, but still not every experiment not working. There's a lot of problems, and then we work together and really efficiently. And the next week, we made some progress. Some of the experiments they started to work, and yeah, that's we start to shift out the laboratory working on the I work to the coronavirus.
So can you describe, I guess, in a little bit more detail, the work that you've done with the coronavirus, the system that you guys had generated?
The first experiment I did in here for the COVID-19 is at that time we have the problem for the virus cannot go to the really high titer, because if you cannot get the high titer, you cannot do any experiment. We figure out this problem and make the virus go to the 10 to the 7 and 10 to the 8. We can do some of the works, and then we got some really promising inhibitor named apinomor. It's from our collaborator in the Boston Children, Tom Kirkharson's lab. He have really long time collaborator with us working on the entry project. So he sent us some of the apinomor drugs. We want to test in vivo use this virus, and it works really well. When you add the apinomor, really even with low dose, they can still inhibit the virus, infect the cells. And then we collaborated with James Braid in the Max lab, and in some experiment use the clinic isolated virus. It also can inhibit the the viral infection. Actually, apinomer, they works with, they blocking the it's a kind of pig kinase and stop the viral particle fused with the membrane and aggregate the virus in the endosome. So this is the rationale. The paper already published, and it's kind of the mechanism how this small molecule works. I think the rationale are mainly focused on the antibodies and selecting the escape mutant virus.
For the COVID-19 pandemic, how has it affected you as an individual?
Yeah, it's affects me a lot. So I have not yet met my wife and my daughter for almost 1 year, because last October, my wife take my baby daughter, Mina, to Japan for traveling, and then go back to China, stay with parents for the Chinese New Year. And as you know, there is a COVID-19 pandemic happened in the Wuhan in China, and I'm worried about them. So they moved from city to my parents' place, countryside, and during over there, they after 3 months, this pandemic happened in all over the world, and right now it's here, and they are worried about me. But I think during this 1 year, I really miss my daughter and miss my wife. The children, they grow up every day, they are changing, and every day they will give you some surprise. But I do the video call a lot with my daughter and my wife. So she's changing. I still remember we talking a lot, and my daughter finally said to me, "Daddy, I love you. Could you buy the pizza for me?" And then I think about it. Yes, sure. I have one more question. Do you love Daddy or love pizza? And she think about it and replied to me, I love Daddy by the pizza. And I feel I miss the timing she's growing up.
And are they going to stay in China for a while, or is the plan for them to come back here?
They are planning to come back to here when the things get better. Original plan is that they spend the New Year over there. They normally come back in the March, but this year looks different. Maybe we'll go to the end of this year or the start of the next year.
That's hard. Do you have any free time during the COVID-19 pandemic? And if so, have you picked up any new hobbies?
Actually, I'm a basketball fan. Before COVID-19, I normally I'm the fan for the Kobe brand, but it's a pity there's an accident happened for the Kobe brand. I normally do the play basketball in the Saturday with my friends, but it's because COVID-19, we need to stop it. Even you go to the basketball in the park, the playground, they take the ring off from the playground, so it just stops the people get together. But it's good to stop the virus spread infection. So I shift my hobby to the biking and the running. Here there is so fantastic park, forest park. So in the weekend, I just biking over there and running over there, and make me feel fresh and have the more energy working in the next week.
As a virologist, how do you make decisions about how to keep yourself or your family safe? So how do you think about sort of how you go out or how you conduct yourself during this pandemic?
For me, it's really simple, just home and laboratory. And in the lab, we always wear the mask, and we are lucky we have some space. We can keep the social distance. At the same time, in the laboratory, all the things happen in the Zoom, like we are doing right now. I think for my family, during the January, they are in the really serious situation. What I recommend, just go back to my parents' place, countryside, not so many people, and they buy all the things from the internet, and they also enjoy the life over there. I think for my friends, it's just take care of yourself.
All right, great. So I guess we're winding down. Do you have any last messages for our listeners? Any thoughts about the future of the COVID-19 pandemic?
I think I hope all my friends and our community safe. And as you know, in the world, there is a huge scientific community working on the COVID-19. We work on the vaccine. We work on the neutralized antibodies. And also there is a lot of lab working on the drug inhibitors. I think, but you can imagine over the world, there's so many universities and institutes and companies, they are making the progress and try to get the vaccine. And right now there's so many vaccines on the clinical trial. So I think you just need to wait, and we will go back to the normal life.
Thank you, Zhuoming, for talking with us today. Zhuoming's previous studies using chimeric VSV to study virus-host interactions allowed him and his collaborators to make and use chimeric VSV SARS-CoV-2 viruses to permit BSL-2 level studies to rapidly advance COVID-19 related research during the pandemic, including ongoing studies to look for therapeutic antibodies and antiviral drugs. This has been Let's Meet the Virologists, a podcast about people who study viruses. This is your host, Larissa Thackeray, and thanks for listening. You can find us on Google, Apple, and Amazon Music podcasts, as well as at lmtv.podbean.com.